Everyone, we're back with example 10-2 this time. So in this one, it's got quite a long problem statement. I'm going to go ahead and read it out, and then I will draw it if I need to. So it says a 1/2 inch diameter aluminum specimen, similar to that shown in figure 10-1. If you go back to figure 10-1 in your textbook, that figure looks a lot like, let's see, all the way further back here. It's a standard tension test specimen. So it has a nice little cylindrical center, and it's got threaded ends. And it's supposed to be completely like perfect. Like, you know, you're supposed to know exactly what's going on there. Okay. It's subjected to a tension test. So after rupture, the two pieces are fitted back together. The distance between gauge points, originally 2 inches, is measured to be 2.83 inches. And the final diameter of the specimen is measured to be 0.38 inches. Calculate the percent elongation and the percent reduction in area. Okay, so I got some tube, more or less. And we stretch it. It snaps. What we're left with is 2 pieces, which should have some sort of necking in the middle, so let me do a little bit better job of drawing that. Okay, there we go. And so with this, we're now trying to determine, well, what is the change in this point? Like we have these 2 points here, now these 2 points. And we had this width before, and now we have this width at the end. It's asking us what's the percent change in length, percent elongation, and the percent reduction in area. So for any sort of percent problem, it's always final minus initial over initial times 100. That's what it always is. So for percent elongation, we're going to do final minus initial length over the initial. So that would be 2.83 inches minus 2 inches all over 2 inches. 2 inches was my initial length. 2 inches is my initial length. 2.83 inches is my final length. And if I calculate this correctly, what I'll get is 0.415. Now this is the fraction. I multiply that by 100, and that gives me 41.5%. Okay, so that one's pretty straightforward. Percent reduction area isn't quite as easy. It's not hard, but it's not super easy. Because I'm given the diameter, and I've got to use that to calculate the area. Luckily for us, you can calculate the area of a circle from the diameter. So we'll do that for both of these. So original, and it had a diameter of 1/2 inch. And then therefore, if I plug that into my area equation, which is area is equal to pi over 4 d squared, what I get is pi over 4 times 0.5 squared, and that's going to be 0.196 inches squared. And then final, it's gotten thinner because we stretched it. And that means it's going to have a diameter of, let's see, 0.38 inches. And therefore, the area is equal to pi over 4 times d squared. And I plug in my numbers. And I get pi over 4 times 0.38 squared. That's going to come out to be 0.113 inches squared. And if I want to do the percent reduction in area, it's always final minus initial over initial. So I'll do that right now. So final minus initial over initial. And I plug in my numbers, and I get 0.113 minus 0.196 over 0.196. And that will come out to be negative 0.423. Multiply that by 100 to get to percent, and I get 42.3. Now, it did ask for percent reduction, and so I don't have a negative sign here. I have a positive sign because it got reduced. So 42.3% is our answer. Okay, that's the end of example 2. In this one, we learned how we calculate percent differences and percent changes in area. We have the final minus initial and initial. We also remember that we can calculate the area of a circle using the diameter. So for those 2 things, we were to solve this problem. Look forward to seeing you in the next one. Have a good day.